Okay, guys, we'll get started. So welcome to our presentation. So our work is focused on Apache Ranger Hive Metastore security. This is Yan Zhou, and I'm Tan Ping. We're the lead architects at IBM Silicon Valley Lab working on the IBM Big Insights product. Just some general background information of Apache Ranger. I think most of the audience would know Apache Ranger provides a centralized security management for Hadoop platform. It gives the capability for authorization and auditing. And then right now, Apache Ranger works on HDFS, Yarn, Hive, HBase, Kafka, Solar, and Knox, and also Storm. Our work is focusing on how Hive Metastore security is providing an authorization for Hive. This is some general background information for currently how Hive Server 2 and Ranger authorization model is working. Supposedly, we have two types of access to the Hive Server 2. The user can access Hive Server 2 using Beeline, and then the user application can connect to Hive Server 2 using JDBC connection. Once Hive Server 2 got the user request, it will invoke the Hive Server 2 Ranger agent, which has a copy of the Ranger policy, and then it will help Hive to make a decision on either to grant the privilege or not. On the other hand, Hive Server 2 Ranger agent is periodically pulling the security policy from Ranger security policy manager. And then if you wish, if the user wish, all this auditing log can be pushed into DB for auditing purpose. We see three major gaps in the current working model. By the way, the Hive Ranger authorization model works great. This is the recommended way to secure Hive right now. However, there's always space to improve. We see currently three gaps in the current working model. Certainly for the legacy Hive CLI, which is supposed to be deprecated, but however the legacy user loves to use it, it doesn't work with Ranger today. Hive CLI have direct access to HDFS. Hive CLI can access Hive Metastore. This is number one gap we see. Number two gap we see for Hive Server 2. Hive Server 2, the Ranger authorization model works great. It provides authorization echo to database, to table, to column, to logs. It supports the Ranger policy creation by the Hive grant and revoke statement. However, it still has some space to improve. It does not support the modification of Hive created policy as a result of DDL. What do I mean by that? Once the database object name is changed from DDL, the Hive created policy in Ranger is out of date, is out of sync. Also, once the database object is deleted, the Hive related policy is still in Ranger policy manager, which it becomes often. Thirdly, the third gap we see is we know for the Hive authorization model, there's the so-called storage-based authorization and also SQL standard-based authorization. The storage-based authorization is mainly working for Hive CLI. It is good in the sense that it provides consistent echo access control between Hive data objects and HDFS files. However, it does not provide you granular, finer granular access control like on the columns. On the other hand, the SQL standard-based authorization model, it fits well in the SQL standard privilege model. It provides the more granular access control, such as on columns. However, it does not provide consistent privilege between Hive objects and HDFS data files. So third-party application using MapReduce or using Pig would be having trouble accessing, there is a consistency between the Hive objects and HDFS data files. Thus, there is a need for us to provide a consistent view between Hive and HDFS. So we all know these three gaps are existing in the current Hive Server 2 Ranger authorization model. So we introduced the new Hive Metastore Ranger security agent. What it does do is to fill in the three gaps here. For Hive CLI, it provides echo for Hive CLI. On the right-hand side, you can see there is a user example. Select star from table employee. Before, without our work, Hive decides the echo on its own. After our work, Hive CLI will invoke Hive metadata store and Hive metadata store ranger agent. Hive metastore ranger agent will help to decide the privilege, to grant or deny the privilege. And then for Hive server 2, it provides authorization for the Metastore objects. Certainly also the echo is in sync with the SQL objects at all the time. The use case also on the right-hand side, if we, for a Hive statement, we grant a select on table employee for user HR1. Now I decide to change the table name from employee to employees. Before our work, without our work, these changes will not affect the ranger policy, so that the ranger policy will be out of sync with the Hive object. After our work, the ranger policy will be in sync. The ranger policy will be in sync with the renamed Hive objects. So for HR1, we have privilege. We can decide the privilege for on-the-table employees. So for the third use case, for resource echo sync-up, we can provide consistent access control between Hive objects and HDFS data files. Use case on the right-hand side, we create a table employee by user HR1. We load the data from a data file to table employee. Here, before our work, what happens is in Hive, the table is owned by HR1, but the HDFS files are actually owned by the useless account Hive. So now what happens is if we use pig to load file into this, to load files into HDFS, it will get denied before because on HDFS, as a user HR1, I don't really have privilege. However, after our work, we tend to make this happen that the pig load is allowed by user HR1 because the ranger policy is in sync between HDFS and Hive. So now Yan will give you more details into the 3 use cases and its implementation.
Hi, let's first go through some typical workflow. So first of all, let's see what happened when Hive CLI is used with the new Hive Metastore security agent. First of all, the ranger admin set some policies for Hive database tables or columns. Then the Hive CLI users will issue some request, say, give me some data, doing some query, right? Then the Hive CLI, in this case, will invoke the ranger Metastore agent for the authorization and for any echo sync as a result of DDL, if that request is actually DDL. So the ranger Metastore agent will check cached copy of the ranger policy, which has been periodically refreshed from ranger policy manager. And then, as the last step, optionally, the audit log could be persistent to a ranger audit database. So that's a typical workflow for the Hive CLI working with Hive Metastore security agent. Next is for the Hive Server 2. So Hive Server 2, once again, initially, the ranger admin will set or create some policies for the Hive objects, databases, tables or columns. Then second step will be for the client to issue requests to the Hive Server 2, right? Then Hive Server 2 will use the existing ranger agent for authorization, which is step 3. So this path already exists. So after that authorization is done, the next step will be to invoke for Hive Server 2 to invoke ranger Metastore agent, which is new. So the purpose of step 4 is to do the echo sync as a result of the DDL. commands. Okay, once the Ranger Metastore agent gets the metadata information, it will extract the necessary information. Oops. Sorry. Okay, come back.
I think he is controlling the back. He's controlling. Okay. Slide 9. Yeah, that's good. Oh, one
The
more.
previous one.
Previous one.
Previous 2, yeah.
Previous.
So
Okay,
8.
stop. Yeah.
Yes,
Right.
this one.
Yeah.
Okay. So the Ranger Metastore agent will use that information, will pass that information to Ranger Policy Manager to do actual sync of the echoes. These echoes could be, the echoes, the original echoes, but on different database objects. Or it could be HDFS, the echoes of the HDFS resource, the HDFS locations that store the Hive data. Can go next. Okay, so this one, let's take a more detailed look at the HDFS echo sync. So in this case, there are 2 scenarios that could trigger the whole workflow. The first one is the Ranger admin may create or change the policies against the Ranger policy manager. So in that case, the updated Ranger Hive policy would cause the corresponding HDFS policy being changed, being adjusted, right? So another scenario is a client, SQL client, say doing create table or do some other DDL. So that will cause the Hive server 2 to pass the Hive metadata to the Ranger Metastore agent, which will in turn pass the related HDFS security info to the Ranger Policy Manager. So then Ranger Policy Manager will adjust the corresponding HDFS policies, and that changed, updated policy will be refreshed against the Ranger HDFS agent later on. So then eventually, the same user may use another, non-Hive application such as Pig to read the Hive data. So that operation will eventually send a request to the HDFS NAND node, which will invoke the Ranger HDFS agent. Then the HDFS agent will check its local copy of the adjusted Ranger HDFS policy, which has been refreshed from the Ranger Policy Manager. So that's the workflow for the HDFS echo sync. So this is the implementation. Some implementation details of the agents, right? So right now, currently Hive has three security-related hooks. The first one is Hive authorizer, then the Metastore event listener, and the Metastore event listener. The later two APIs are for Metastore security purposes. Would you go?
Next.
Next. Yeah, the existing Linear Hive authorizer actually implements the Hive authorizer interface.
Next.
Go next. But for the new, we actually have two new Metastore agents that extends the Metastore pre-event agent and the Metastore event listener. Actually, it's okay now. Okay, can you get down? No.
Previous. Can I check this? Next. Next.
So this is a little bit more details about the implementations. So the first range Hive authorizer is the existing implementation of the first Hive security API. Right? It handles the Hive Server 2 authorization and grant and revoke SQL calls. The next two are the new Metastore-related security agents from us. So the first one basically handles the CI authorization before any Metastore operation is invoked. The last one is after the Metastore operation is invoked. So it handles the sync of the echoes, which could be Hive database objects or the HDFS echoes. Handles the sync of both echoes. Okay, currently we have a patch ready for CLI access control and policy object sync as a result from SQL DDL. The HDFS echo sync is still ongoing, so it's not quite ready yet. So for more detailed information, please go to the references listed below for more details. So next we are going to do some demo. The demo will be on two test cases. Right? The first one is we're going to run the both CI and Hive Server 2 with the Hive Server 2 existing Hive Server 2 agent enabled, but not with the new Hive metadata security agent enabled. So that's the existing behavior. Next, we will compare with the new behavior without with our work on the Metastore security agent enabled. So can we switch to?
Now we need to switch to our computer. Okay, it's on.
It's on here? Okay. So this is the existing, range policies, right? So it only has policies for the Hive as a user, as kind of super user for Hive, but no other policy for any other users. We're using a Kubernetes cluster. So right now we are, working as a user Yanzhou. So right now it's configured to use just the existing Ranger Hive Server 2 agent, no Metastore agent. So we are using Hive CLI now. So we're trying to create a table called employee. So it's allowed. But from why it's allowed, the Ranger policy, remember the Ranger policy does not have any privilege, any policy for any user other than Hive. It's allowed because it's still using the Hive native policy, which could be shown from here. So user Yanzu is allowed to create, to create user in a default database. So it's allowed, but it's not using any Ranger policy at all. Otherwise, it will be disallowed. So it shows that without the Ranger, without Ranger Hive Metastore agent, it's not going to work with the Ranger policies. So how about Hive Server 2? We're starting a Hive Server 2 now. For this, we're trying to switch a user to the kind of super user. Hive. So we are connecting to the Hive Server 2. Again, we're trying to create a table of employee. This time it will be allowed because we have the policy. Oh, okay, already. This time it's allowed because we are using an existing Hive Server 2 Ranger agent, right? So we have the policy for the Hive to do create table. We just see there are two policies. The interesting thing is now we are trying to grant the select on table employee to another user Yanzu, which succeeds. Let's take a look at the policy, what's Ranger policy, to see what happens. So there's a new policy created. This is actually automatically created by the grant command, SQL command, on the table employee, which gives the select privilege to user Yanzu. This is the existing behavior, but when we try to do something more, say we try to rename table employee, to employees. The policy remains unchanged. It's still untable employee. Again, this is existing behavior without using the new Hive Metastore security agent. Furthermore, if we do job this table, the table will be jobbed. But the policy, the newly created policy by Hive, grant, commander still remains. So it's pretty much, orphaned. So this one, policy remains there, right? Even though we have deleted that table, employee or employees. So it still remains. Let's delete it manually. So we have to remove it manually. Okay, this is the existing behavior. Let's try to enable the new Hive Metastore range agent. First, we kill the Hive server 2. Then enable the So now it's still using the older behavior, right? So we will relink. So right now it's using the new Ranger Metastore security agent. Let's first try the Hive CLI again. Sorry. User 研究. That's a normal user. So it's disallowed because we don't have a range policy allowing such a user to do anything like table creation. Let's try Hive server 2. Starting Hive server 2. Once again, we create a table called employee, which should be allowed. Then we grant the select privilege to a normal user. So again, we will check the range admin. So again, there's a new policy created as a result of that SQL grant operation, which is on table employee for user Yanzhu and with the permission select. Then again, we try to rename the table to employees. Okay, last time, okay, job. It's a leftover from last test, so we just job the table. Okay, rename the employee to employees. Okay. So you can see the policy has been automatically synced. The table name has been changed to employees. Right? It's the same policy, but it's on a renamed table. Lastly, if we job that table, and we'll see that policy has been automatically removed as a result of that DDA operation to job the table. Okay, that concludes the demo. And the next is the Q&A session. Any questions?
Are there any questions? Yeah.
So Ranger allows policies on, like you can say, all tables is starting with A star user.
Yeah.
Right? So how do you deal with that kind of policy when the table rename happens?
Oh, okay. When the table rename happens, the early affected policy are the policies that have been created as a result of the SQL grant operation. So if you manually create a policy from the Ranger admin, like using the wildcard, right? It's not going to be affected. It's only affected Hive created policies.
Like, so you distinguish that in the
Yes. Yes.
Hive created or
Yes.
UI created?
Yes. We cannot ascertain all policies, right? Because we only the automatically created policy as a result from grant will have that association between the SQL command line and the Ranger admin.
Yeah, sure. A second.
It's like Hortonworks HTTP like 2.4, and I think this is not part of that, right?
No.
Well,
Something
yeah.
enhancement that IBM did to Ranger.
We're trying to get this into, oh, well,
Please repeat the question.
the question is this work in the HTTP 2.4? So we're actually from IBM, but this is a community work. So whatever we do is contributing back to Ranger as Apache Ranger open source project.
So we'll have to check with.
But it doesn't, it's not,
What part of the HTTP?
right, but then the release HTTP doesn't have this yet. I think that this fall a little bit behind. Yeah.
When will this be available on the community website? I thought I heard something that you mentioned it wasn't available yet.
Yeah, so firstly, it's available in Apache Ranger, but then when HTTP releases it, it's a decision, from Hortonworks. Yeah.
But you can download this now.
The patch is available, yes.
Patch is, yeah,
Right,
you need to do the more. It's not in the,
It's
in
not
the chunk
packaged
yet.
in- yeah,
It's
it's
not
not packaged in
version
HTTP yet.
Yes. It's still on development.
Committed to the trunk?
The patch is available, and then it's not committed yet.
Okay. So in that demo, are you running that Metastore as a separate print service, or was it part of the Hive server too?
It's part of the Hive server 2 right now. It is all on a virtual machine, one virtual machine right now.
So will this feature feature be supported when the Metastore runs as
It's
a
a two
separate
processes.
print service?
I'm sorry, say again.
Will this feature be supported when the Metastore runs as a separate
Yes.
print service?
Yes,
Yes.
yes. Yeah, please.
Are you using the security at IBM right now for any purpose?
We are. So our
question?
the question is, are we using this security feature for IBM for any purposes? We are. So our IBM release contains Ranger. Yeah. It's a slightly.
Your data on your Hadoop cluster that
Yeah. Right. So basically, our release, we have a little bit of flavor from IBM. So we take most of the stuff from open source like Apache, but then we have IBM offers as well. So IBM is good at there's multiple packages from IBM offering, yeah, like Guardian or yeah.
You need Kerberos implemented for the Ranger?
So the question is, do we need Kerberos implemented for Ranger? So that's a separate issue, right? So Kerberos we're talking about, for example, tamping is tamping. But then here we're talking about authorization, which do you, sir, have the privilege? So for Kerberos, this is the Kerberos working for Hadoop right now. So we are not really touching that. We're talking about the privilege, the permission, authorization model.
Is it like a requirement for it to work?
It is not, the question is it required for Kerberos to work? It is not required, but then we recommend you to have Kerberos. Yeah. Yeah, sir.
So the second functionality that you showed, the synchronization of the policies, will that work if the agent, the connection between your agent and Ranger policy store is broken? From what I understand, it works one way.
Yeah,
The
right.
agent can enforce the policies when it's broken, but the sync, will that work?
Yeah, so the question,
No, the thing won't work.
yeah. So the question is,
Well, it's actually for Hive, for the Ranger Hive agent, not just for the Metastore, new Metastore agent, even for the existing Hive Silver 2 agent. If the connection is broken, the policy refresh will not work. The agent will use its local copy, so which means it could be outdated. It could be out of sync with the Ranger admin policy. Okay, but for this one, for the object sync, right? The new object sync, it won't work because it has to. The connection has to be there.
So will you return an error on that?
Yes, it will return exception. It will list an exception.
our time is up, but then we'll stay. If there's anybody have more questions, we're happy to discuss with you.
Thank you all.
Thank you.